And I wish Alf was here. There's a couple of things that really concern me that I didn't bring up Monday. On what's been going on. I was going to put a bug in the two sections, but what has happened is yesterday when I was showing it to my intro to robotics class, we were going over sensors in that class. There's a bug that's in the line. So what we're going to do as a group today is we're going to figure out y'all are going to figure out what's wrong. Can y'all see that green light flashing over there? It will not go off. It will not reset. So this is a true life scenario that's happened to us. So our line is down. A major module in the line is down, which we're going to have to fix. This is not a bug that I put in the line. This is in there. And I have no idea what it is. I hope so. I got confidence in that. A couple of things that I know it's hard to do, guys, but, and I heard this comment, and it happens all the time, is you try to figure out what Rich would put in the line. So instead of trying to figure out what's wrong with it, you say, well, I didn't think you would do that, right? And what we're doing is we're troubleshooting problems, so don't put anything past me, right?
Yeah, wait a minute. You're saying that we're that smart. We're not that far along yet.
Well, you are. I mean, that's the comment I hear every time I taught the class. Believe it or not, every time I taught the class, somebody has said what? You're troubleshooting on what you think I would put in the line, and you don't troubleshoot the problem. Of course, we talked also about the function chart and trying to figure out where it actually stops at. And what the problem over here is this guy right here will never, ever, ever start. So this is the sorting and queuing line section that we're having a problem with. And we're going to talk about looking at this a little bit the other day. Because we have this line makes a decision. This section makes a decision. So what it does, if it's acrylic, it comes down this line right. Y'all can't see me. It comes down this side right here. Where if you're looking from the back, it goes down the right side, and then if it's metal, it comes over here and pushes it over to the left side. So this makes our flow chart and our flow chart or our function chart a little different. So here's all our sensors. Of course, this is the manual that we have. So we have an inductive sensor. So we have a photoelectric sensor, B1. What's B1 doing for us? Yeah, it determines if something's there. And then B2 tells us if it's what?
Inductive magnetic metal.
Yeah, it tells if it's this metal, right? You understand. This is a diffuse sensor, so it bounces off, so it's got a retroreflector over here. Then what it does is it starts moving down the line, and then if it's metal, what's going to happen is this guy right here. So 1B1 and 1B2, it says magnetic reed switches, but I've noticed that Siemens makes a few mistakes. We'll look at that. 1B1 and 1B2, these are determining if the sorting cylinder is either extended or retracted. So if it's metal, what's happened is the PLC will cause this to extend out and move it over to this track, or what they're calling track B. If it's acrylic, it just lets it come through. Then what it does, it works off a timer. So there's a timer that comes into play that determines when these guys right here open and close. And so what it'll do, it'll come up here, it'll hit this, and then the belt will keep running. After a certain amount of time, it'll open up and then it'll close. So if there's a block behind it, it will stop it. We do have a problem with this we might look at, but it was something else. Sometimes this closes a little too late, and what it'll do is it'll grab the whole of the next block. I don't know if y'all noticed it before. I've never seen it on this side, but I've seen it on that side. And then what does this guy right here tell us? B3. Yeah, something's there. So it tells the robot station. So this is why this is where that cable that goes between the stations. This is why the robot station knows that there's something. It runs the conveyor belt for a certain amount of time. There's other things that it does. It keeps counting with the block. It keeps count of the blocks. So the program knows how many acrylic blocks you have and how many metallic boxes, metal boxes that we have. So that's in the PLC program.
Where does it record that information? How that it gathers it? What does it do? Counts the block. Can you see it somewhere?
It's the PLC that's doing it.
Why? If we can't retrieve that data.
Because it's got to know when you get so many blocks there. So it's not going to fill the belt up. So what the Festo line does is that on what they call the buffer station, it waits on a sensor to clear. The way this works, if it's got so many blocks down this, which usually comes up to right about here, the line will stop until the robot comes in. Plus, it's got to keep up with how to feed this right here. So if it comes down here and sends a block, and if it comes down here and sends a block, and it's got a mail block over here, and it's got another mail block, and it's got that, how does it know when to open and close and open and close and keep letting blocks through, even though I'm not feeding blocks in there? Well, the PLC keeps up with a counter.
It's set, not let any more. Let's say it's going down the metal side. Some of it would stroke it over. And if there's too many in there, it would just jam blocks up.
Yeah, it would. It would jam blocks up. But it would be okay because this sensor right here would never clear when it got so many in there, which is the way the Festo line works. So the Festo line on the buffer section, it's got a sensor back there, and if it don't clear, which means it's got too many blocks in there, then everything.
Well, that would be a reason.
That would be a reasonable thing, but that's okay for that line because it's not sorting. So what happens? It's not moving things around. What we don't want to happen is we don't want the belt to run with blocks back in here, because what would happen? Well, some of them would track over and get out of the way. So what's happening is that this line, once this thing gets back into right about here, no matter which block is there, what it'll do is it'll stop all the feeding sections. Everything will just stop until the robot comes up here and picks something up. Well, when it picks something up, it decrements the count, and then now all of a sudden the rest of the line knows it can feed another block. So that answers your question, Jerry? And no, we can't see the number because it's something that we don't really need to know.
It has a purpose.
Yes. Yeah. So it's got two purposes. It lets the conveyor belt know that it's through with what it needs to do, and also if it gets full, it'll stop the rest of the line until we clear that out. Right? So you okay?
Are those manufacturing line documents? Yes.
Yes, they're on. This is module number 4.
Sorry.
Yeah, so this is module number 4. And of course, this is standard. And what I've noticed, and I probably need to go back and try to put notes on that, is that when we get into the function charts and the flow charts, they don't even tell us about these switches right here. The only one they always mention is the start switch. So I was back there trying to figure out which PLC input was good, and then I realized one that was lit all the time that wasn't in the documents. And when I went back and looked it up, I think it was one of these switches right here. It was the power on switch, which is very, very important. Of course, that's pretty obvious because they turn on an LED. So these are magnetic reed switches. So I know they're magnetic because of the little trough thing right there, right? You understand? So this indicates magnetic. And since it's only got 2 wires coming into it, I know that it's a reed switch. If it had 3, it would be a Hall effect, right? So these are our, this is our inductive sensor. This is one of our optical sensors, and this is one of our optical sensors. These are our, and they didn't put the symbol right for some reason. They do sometimes, and sometimes they didn't. But these symbols right here should have a slant in the center, because this is the international symbol of a resistor. Normally the resistor, though, the inputs are going in and out. So over here we learn a resistor as that jagged line. The international symbol for a resistor is a rectangle with 2 wires coming in, coming in. The international symbol for a solenoid has to have a what? Needs to have a slanted line right here, indicating that.
So that's why we tell it's
Not a transistor, a resistor. It's obvious it's not a resistor because the leads are coming in on the side. If this was the international symbol for a resistor, of course we know what our symbol is. And guys, it won't. Yeah, that's what we use. But the international symbol for a resistor is and believe it or not, I like it a lot better, because most people, when they try to do this, mine ends up looking like an inductor. The international symbol for a resistor is a rectangle with 2 wires coming in. Yeah, the inductor would be black in. And the international symbol for a solenoid should be like this. I don't know if the slant is right or not, guys. And then the leads come in from the side. They don't come in on the bottom. So that legally on the and you can see it on some of them. They put the slash in there, and some of them they don't. I mean, it's no big deal, but we know it's a solenoid. So this is not the valve. This little rectangle, these little 2 triangles right here, that represents the valve. But this is not the valve. This is the solenoid that controls the valve. Y'all understand that? And that's a big mistake people make. They say it controls the direction of the cylinder, but this controls the direction of the valve, and the valve controls the direction of the cylinder. This is the terminal board layout, and this is a pretty good one. I'm gonna blow this up. So this gives us all the names, and this tells us the designator on the diagram, right? Are you okay there? Now this tells us that same thing. This is a little better because this not only gives us the symbol or the designator, this also tells us what port on the PLC that these are hooked up to. And then what I wanted to make sure we looked at, and this is step chart, but I wanted to make sure we looked at the function chart right here. So notice this function chart is a little different than the one that we used to, because of why? It makes a decision. So one route is metal, it goes one way. One route is acrylic, it goes the other. You understand that? So here's where it says it does what? This increment acrylic, this increment alone. That's where the PLC, and once it comes out, when it releases a part, what does it do? Decrement. Does that make sense? This right here is releasing the part, so that's that single acting cylinder that's on the very end. That when it releases it, then it decrements it, right? The problem is that it decrements it no matter what. So if one gets caught, that's the problem we have. And there's absolutely no sensors on this guy right here. And it's strictly done by a 1 second time delay. It's going to extend the cylinder. Then it's going to do what? Retract it. It's going to increment. Says we got aluminum. It's going to release the part. Okay. And then it's going to what? Yeah. And then it's going to do what? Start over. So start the motor when it senses part receive input. I think they've left something out right here. Oh, I'm sorry. No, go ahead.
Start with reading up all the modules, sign the system. So if something happens on module 1, well, let's say module 2, because that's what I was. Does that light blink? If something's jammed?
Well, it depends on what causes the light to blink. Normally, and this is something I couldn't find, of course I didn't have much time, is normally it blinks when some sensor is out, it's not in the startup condition. So if we come over there, I said normally. So if I come over there and start, let's say the carousel, and I've got a block sitting out there, and the power's being turned off, and I come over here and turn it on and reset it, it's going to start blinking, because when we reset it, there's not supposed to be anything on the line, right? So normally what we notice is in the PLC program, normally if a sensor is not in the right situation for startup, then that's what it usually does. And it means you got to clear the line or something. You've left a part out there. That's usually what we notice is the part's been left out there or something else is going on. So that would probably be one of the things to start. This is what I wanted to show y'all this next chart, but y'all can understand. So this is a little different than the function charts. By the way, if I call this a flow chart, I'm an old programmer, and we used to do flow charts, and this is basically what the flow chart would be. But what we would do up here in a flow chart is we had a symbol. We called it a decision-making symbol. They don't do here on that. They just split it out. So depending on the results of the if B2 is equal to 0, it's going to take this path. If B2 is equal to 1, it's going to do what? It's going to take that path. No, the function chart don't know that. That's built into the PLC. Now, what it might tell us, and that's a good question, Brandy. I didn't look, but back here where it comes up here and gives us a function of back here when it explains the operation, which I like about this. Most of the stuff I've seen when I've got on, we don't have this right here. So what Siemens has done for us is they've given us basically a detail operation. Now it might be in that cylinders, but I imagine it might be on the line or 5 or 4 or something like that. We could, when we get it going, that's something we'll do. We'll let it fill up. So we won't start the robot, and we'll just let it fill up and see when it actually stops the rest of the line. So that's a real good question. And then what we can do, anything that's not documented, once we notice these kind of things, that's something that we might come in and add to our document. So at UF Steel, we had basically, especially like at number 4 galvanizing line, we had a document case out there where anytime we made a modification, that's one thing we would do. We would document it. If we found something that wasn't on there, we'd document it. The biggest problem though is we had another set back at the shop, And it was up to us to make sure what? That we documented at the shop. Unfortunately, that didn't usually happen. So what you'd end up with is you'd be working back here and you'd try to make a sequence that, well, let's try this first, and you'd go up there and you'd see all these notes on the diagram. That's just live. Now this chart right here, this is really, really, really neat for troubleshooting.
That's what we found out.
Yeah, I really like this chart. This chart right here tells us exactly what we are looking at or what. Starting. Remember, receive an input. Once we receive an input, it says this guy here is going to change. It's going to change states, right? You understand that? Then we flow down through here, and it tells us what we're looking at to get this guy here each step. So what happens on these inputs and what should happen on these outputs. I like this one for this condition right here. Normally, for the rest of the conditions, it's easier to see that right here. Because here you can say, okay, to get from here to this guy, then B1 has got to be what? It's got to be okay, right? You understand that? So 1B1, this has got to be true to get down to this next step. But that startup condition is very, very limited up here because all we got is this little old line right here that don't really tell us exactly what's required to start it. But when we go down to this guy, it tells us exactly what's required. Sorry, I went too far down to get it to start. So what we have now over there is we've got station. We'll have to break it out. By the way, these things are on rollers, so what y'all can do is you might have to disconnect power, but what y'all can do is don't break the other sections apart. Just break it off and roll them out as a unit, right? You understand that? And that will be a lot easier. You're going to work on this as a class. Because it wouldn't be, and this is a real problem. Like I said, this popped up yesterday when I had my intro to robotics class over here. It popped up yesterday, and now we got a problem. You can see it from over here, right? So we need to write the gripe up. I guess the gripe will be module 4 will not reset. I'll go ahead and take a break and we'll come back in and look at this.